Hey everyone, welcome back. Hope you all are doing well. And let's start the problem for today. So, what we are going to discuss today is this problem: array to binary search tree. Let's understand the problem statement first. You are given a sorted array. Convert it into a height balanced binary search tree and then find the pre-order traversal of the BST that you are going to create yourself. And if there exists many such balanced BSTs, consider the tree whose pre-order is lexicographically smallest. Okay, so height balanced BST you already know, which I'll explain again as well. We have taken it in our previous lectures, but let's understand. Let's take this problem, the second test case, and I'll explain it to you. Okay, fine. One sec. Let me check if we are live. Yes, we are. Cool. Let me take it. So the example here, what we have is this tree. Basically, what you're given is in an input array. This input array is 1, 2, 3, 4, 5, 6, 7. So what you're observing here is that you are given a sorted array. Okay, so from this sorted array you have to convert you have to create a height balanced binary search tree. Okay, now first thing is, what do you mean by height balance? So you know, when any height balanced binary tree or binary search tree is the difference between the leaf node. For example, this is a tree. Okay, so if you observe, this is your root node. Any subtree's height should not differ by more than 1. What do I mean here is, if you consider this subtree, it is height balanced. The leaf nodes and the root, they are this is at the same level. If I consider this subtree, the height of this subtree is 1, 2, and the height of it is 1. So all the subtrees are height balanced, so the entire tree is height balanced. For example, if I consider like this, so if you observe the height of this subtree or this particular subtree, 1, 2, this subtree is balanced, but this tree, the left height minus right height, okay, mod of that should be less than or equal to 1. It should not exceed than that. So if I see this tree 1, 2, 3, and the height of left subtree is just 1, the height of right subtree is 3, so the difference is more than 1, right? This is the reason it's not height balanced. So height balanced we have already discussed, but this was a little brief to it. Fine. So you have to convert a BST from a given sorted array. So how will you do it? You already know the property of a BST. The left subtree is going to be less than the root and the right part is going to be greater than the root. So for that, what solution we have come up with is that, see, it's again simple observation. We will take the middle element of a sorted array as a root. Now what are we going to do from here? That all the elements before the middle element should lie in the left subtree of the root. Okay, now how to arrange them we will see. And all the elements to the right of 4 in the array should lie in the right subtree of 4, the one which we have chosen as a root. So we are choosing the middle element as a root to create a BST. Now this will be again these will form the right BST. But in what order should it be? If I consider the left part, I know all the elements that should lie in the left subtree, but I do not know if they should be like this, if it should be like this, okay, or it should be something like this. We don't know. There are multiple possibilities. So how will you ensure that again this part also is a binary search tree in itself and height balanced BST? So the thing that we did here in the entire array, we will be repeating the same thing for the other subtrees, the left subtree and the right subtree. So now if I consider these elements, I will pick the middle of these elements. So the middle of these elements is going to be 2, and I will make this as the root of this subtree, and I will ensure the elements that are to the left of 2 will form the left subtree and the elements to the right of 2 will form the right subtree. Now I can see that I have only one element towards the left and the right, so there is no more thing that I need to do, means no more bifurcation. So this comes out to be left, this comes out to be right. If you observe, this in itself, this subtree 1, 2, 3 is following the property of a BST, and we already chose the left subtree to 4 in such a way that it will follow the property of a BST. That means all the elements will be less than 4. Now this was another task to ensure that left subtree itself is a balanced BST. So one thing you can see from here that we are going to make use of recursion here again, because we are recursively solving the same problem for the left and the right part, okay, and in the beginning for the whole array itself. So this thing is going to be taken care by recursion. How we will take care? Now if I check up the similar thing for the right subtree, I choose the middle element of this array, okay, of the elements that I have here, 6. Then I will take the left element in the left subtree and the right element in the right subtree, and this is how my tree has been created. So finally what you have to return here is that you return finally the root of the BST that you just generated, correct? So once you have the root, you can do all kinds of traversals, but the question asks you that you should be giving find the pre-order traversal of the height BST, and the elements that you get in the pre-order traversal, that is what you have to return in the output as an array, okay? So I'll create an array in which I will insert the elements of the constructed BST in the pre-order traversal. So pre-order traversal, we already know what it is. It's root, left, and then right, correct? So once I have the root with me, root, if I want to do pre-order traversal, now let's see what will be the elements that I will insert into my array. So 4, first I will insert the root, then I'll go to the left. So left consists of 2 again. So root, then I go to the left part, I see 1, and then I go to the right part, okay, fine. Then I go further to this right subtree in which this is the root, left and right. 4 2 1 3 6, 4 2 1 3 6 5 7. Got it? So I hope the problem statement is clear to you. If you have any doubts, you can write in the chat. Then we will move to the code part, okay? Now the question comes, what question arises here is that how are you going to handle this thing in which you are going to pick the middle element every time? So this is something that you need to understand now. So what we are basically doing here is that it is quite similar to binary search like we do. For example, I will take I'll take a new function node which will be returning with a root node finally. Node, let's say I'm creating BST, in which I am passing this array. Okay, so this is the function I'm writing which will be recursively taking care to create the left, right, balanced BSTs for every subtree. Okay, then this is the starting index and this is the ending index. So initially when you know my array was this from here 1 2 3 4 5 6 7. So the starting index should be at the 0th index. This should be the start. Okay, this should be the start index, and this here should be my end index. Okay, so this tells me the middle element that I'll choose will act as my root, correct? Okay, so the next thing that I do, so I will take this thing if my start is less than end. Okay, or you can do one thing, if your start is less than end, you return from there. That is your base case condition. Now what you are doing here is that you are picking up your middle element. So middle element you know how to pick up. I don't think so here we will have any issue of exceeding the limit of an integer. So we can simply do start plus n divided by 2. Okay, otherwise you know what is the other way. We use start plus n minus start divided by 2. Fine. So okay, this is one thing. And then what you do, you choose the middle element as your node. So you create a new node. Okay, you create a new node which I have named here node. You can name it anything, be it root or whatsoever. So what will be that new node? It will be a new node whose data will be your ARR of mid. Got it? So this ARR of mid will act as your root now. Right now I've just created a node which is going to act like a root element. This is the root element that I just created for myself. Now I have to repeat the same process to find the left subtree, and it should be a balanced BSTs. For that I know that the elements that I should have should be from the range start till mid minus 1th index. And for right subtree, what is the range that I should pass? That should be mid plus 1 till end. So that is what I'm going to do via recursion. Now this should be attached as the left of this node that I just created. So what I'm going to do here is that node dot left, right, node dot left I'll get from by making the recursive call to this function BST and passing the range. This ARR will be passed as it is, and the range will be from start till mid minus 1. Got it? This is going to be your left subtree, and node dot right will be your BST and passing this array as it is. The range will be from mid plus 1 till end. So you can see from here that how via recursion we are handling this thing, and finally what you return is your root node that you have created. Okay, so the base case is when your middle and start element, okay, exceed, basically your start element exceeds end or becomes equal to end, right? That is fine. But if it exceeds end, that means you are left with only one element and you have processed for that, so you return. And once you return, your function will take care of attaching the left and the right nodes to the root node that you have chosen for that recursive call, and that will be further attached to the other node that you will be chosen, and like this your BST will be created. You can do a dry run for yourself and understand the recursive calls if you need to, but I'm sure that this part must be clear to you. That is all about it. Okay, from here finally we got the root node of our BST that we just generated. Okay, this is the BST that we created. From here we got the address of the root node, that is 4, for example. Fine. Now my next task is to write the pre-order function. Okay, so we know how to do pre-order traversal. Simple thing, we have passed a node root. Okay, simple pre-order traversal. The only thing is I am creating a new array of length equal to what I got from the nums array as my argument. So in this question, if you see, you are given a nums array, so the output's length will also be equal to the nums array, so that can be created. I hope that's not an issue. And then we will write a pre-order function. Again, if your root is null, you return. I'm just writing it for you guys, but we have already discussed this. There's nothing much to do here. Okay, so we are doing in ARR, let's say I've created ARR and I will declare an ARR and the index as my global variable, so that I can just insert values into it. ARR of I++, I'm inserting root dot data, and then I move to left and right. So make a call to pre-order and pass ARR, this root dot left, and again make a recursive call to it. Same function for root dot right? So this is your pre-order function, in which finally your array will be stored with the elements of this tree in the pre-order manner. So these elements will be inserted in your array, and finally the function that you are given in this question is this function that you have to complete. So where is this is the function that you have to complete. In this function, finally what you have to return is the array. So what we have done, now let's have a look at the code. I hope you understood the dry run, you understood the logic behind this. Now it's very simple. I've already written the pseudo code, which is completely what I have done here. The extra thing that you have to do is that in this question you'll see that you are not given any class node that you have to create for a tree for yourself. Okay, so this is the node for the tree that I have created, in which again this is the basic thing, constructor, where I'm initializing the data in the left right nodes. Okay, this is one thing that you have to do. Then as I told you, I have created a global variable of int I and this global array, right? Why? Because I finally want to return array in which I'll be storing values in the pre-order traversal of the tree that I will generate. Okay, now this is the function where I'm doing the task of creating the BSTs. This is exactly what I've written in the pseudocode. Fine. Then this is another function that we have written here, same as what I wrote. So this will be doing the traversal on the tree that you created from here. It is taking the node from the node that you returned from BST, doing a pre-order traversal on it. I am inserting the data into my array, and finally this is the function that you were given by the compiler to complete, in which first this I have just initialized the array, and then I'm making a call to BST function to generate the BST, then pre-order function to fill up the values in the array in the pre-order traversal of that BST, and finally you return the array. Fine. So the code just looks lengthy, but I'm sure now if you have understood, it seems pretty simple. So that is all about this question. Let me know if you guys have any doubts. Fine. Okay then everyone, see you all in the next lecture. That's all for today. Bye bye and take care.